In this video, I am going to explain to solve some of the numerical problems in a frequency modulation. Before going to solve numerical problems on these frequency modulations, we will see the some of the important formulas those are used. So first, okay, frequency modulated signal is represented as VFM of t, or simply FM of t is given by AC cos of omega ct plus MF into sine omega EMT, where AC is the magnitude, omega ct is the carrier frequency, MF is the modulation index, and omega mt is the modulation frequency, modulating frequency. And coming to this MF modulation index is given by, it is a delta by FM, where delta is the carrier frequency deviation, that is a maximum deviates. And bandwidth of the FM signal using Carson rule, it is a 2 into delta plus FM max, where FM max is the maximum modulating frequency. And bandwidth of the FM signal from a Bessel function table or from direct method, that will be equal to 2 into FM into N. Again, FM is the maximum frequency, N that is the number of sidebands that is determined from the Bessel function table. And coming to the phase shift due to the noise, this phi is means there is a phase shift when the signal is transmitted through a free space. That phase shift or frequency shift pi is given by sine inverse of n by s, where n by s is the noise to signal ratio, and frequency deviation delta is simply it is phi into EFM. So these are the important formulas are used. So now we'll see one by one. This is the table. This is the Bessel coefficients for a modulation index. So this first column it is a modulation index, and this first row it is a carrier magnitude, and first sideband magnitude, second sideband, like third. So these are the number of sidebands. First 1, 2, 3, 4, 5, 6. For example, 0, 0, it is only a carrier magnitude. When modulation index is 0.2, it has a carrier magnitude as well as first sideband. When 0.5, 0.94, and it has a two sideband, that is n is equal to 2, and its carrier sideband magnitude is 0.24, 0.03. Similarly, like that, okay, this table is also used to solve the problems when it is based on this Bessel coefficients. So first we will see the one numerical. A 162 megahertz carrier is deviated 12 kilohertz by a 2 kilohertz modulating signal. Compute the bandwidth occupied by the signal using conventional method and Carson rules method. Our delta, that is a 12 kilohertz here, and maximum modulating signal is a 2 kilohertz. From the Bessel function table, MF is simply, so first means we have to calculate the modulation index. Delta by FM, delta it is given 12 by 2, it is a 6. We will see that from the 6, what is the value here, okay. This is the 6, and how many sidebands are there? 8, okay, that is a capital N is equal to 8 here, okay. For 6, okay, sorry, for 6, yeah, this is the 6 here, up to 9, okay. This is the N is equal to 9. Yeah, N is equal to 9. So bandwidth is equal to 2 into 9, that is a 36 kilohertz. So we have determined this N from the table. This N is determined from the table, Bessel function table. So for that we need a modulation index. Carson rule, simply it is 2 into delta plus FM max, that is a 2 into yeah, it is a 2 into FM max, that is a 2 into 12 plus 2, it is a 28 kilohertz. And always this Bessel function is much higher than this Carson rule method. Next, here maximum deviation of a carrier is 2.5 kilohertz signal. Okay, this is a 2.5 kilohertz signal is 4. Deviation is 4 and signal frequency is 2.5 kilohertz. Compute the bandwidth occupied by the signal using the conventional method and Carson rule. Delta 4, 2.5 kilohertz. Bessel function, again MF 1.6. Again, while going for a table, n is equal to 4 or a 1.6. This we have to use the table, means how many sidebands are there. 4 sideband, this we will get it from a previous table. That is the bandwidth is equal to 2 into 2 into 4, it is a 16 kilohertz. From Carson rule, 2 into delta Fm max, 2 into 4, delta is a 4, Fm max is a 13 kilohertz. Next, for a single frequency sine wave modulating signal of 3 kilohertz carrier frequency 36 megahertz, what is the spacing between the sidebands? What is the spacing between FC? They are given, FM is given, upper sideband is FC plus FM. 3 means convert this megahertz to the kilohertz, so that both, because this is kilohertz, this you convert into kilohertz. Okay, this is the frequency of the upper sideband, and similarly FC minus FM 35,997. This is 36,003. And upper spacing between sideband is upper sideband minus lower sideband, it is a 6 kilohertz.